Right. Hi, everybody. Before I get started, can I get a show of hands? Excellent, excellent. There's people here. Wonderful. So the title of my talk is, let's see, Crescent wrenches, socket sets, and other tools for debugging. Okay. That's a very long title. But we'll get into it. For those of you who don't know me, my name is Kerri Miller. I am a software developer based in Seattle, Washington, which is on the west coast of the United States. This picture is a lie. It's not raining. What I love about Seattle is it does in fact rain, but only for about 6 months out of the year. So we'll see the sun again in April. But then it stays beautiful without a cloud in the sky for like the rest of the 6 months. And we don't tell outsiders that very often because we don't want you moving there and ruining it. But I've been in Portugal for about 2 weeks. It's been absolutely lovely, and thank you so much for inviting me to the conference, having a wonderful country. Thank you. You know, we're watching a lot of stuff, news from back in the States about our election. We have some very we have a reputation as a litigious country. This is my lawyer. His name is T.J. Higgins, JSD. JSD, for those of you who don't know, is a law degree. So he has a doctorate in law. That's actually his registered name with like the official breeder and whatnot. People ask me why my dog is named TJ, what TJ stands for. It doesn't actually stand for anything, but it's very convenient because you get to make things up. Sometimes it's trash junkie, terrible jerk, especially at 3 a.m. when he senses that there are ninjas in the house. I've been traveling. I want to thank the organizers for finding a laptop for me. I'm traveling very light on this trip. This is my desktop while I'm on the road. Yes, I built this slide deck mostly on an iPad mini. I am in love with this new aesthetic of traveling light because normally traveling with like my regular keyboard is a little bit hard. This is actually not my keyboard. The one I have is identical to this, the same keycaps and everything. This is my friend Aaron Call. We ended up doing identical keyboards at some point. I'm a cherry blue user, which means that my keys go click, clickety click all day long.
Very good.
I shared an office briefly with Aaron Patterson, and we both had clicky keyboards in a shared office space for a while, with like no walls and anything. It was very great. Keyboards, though, I'm a junkie about it. I've got 3 of them now, so I loved the talk on keyboards, and I was like, oh, that's so cool, I got that one, whatnot. I have a lot of hobbies, though, besides software and keyboards and nerd things. I went to cooking school just for 3 weeks. Don't get excited. I realized I didn't like being yelled at 3 a.m. while making bread. I took a year off from software and became a professional poker player. It was years ago, but it was fun. I used to call myself a glass artist, and then I worked with making beads and pendants and things like that. I haven't made the time to get back into the studio, but it's a lot of fun, something that's not software. I really love hiking. I love long distance hiking. I apprenticed as a marionette puppeteer for a summer. That was a lot of fun. And I've actually written 2 role-playing games that have been published. Right now, I'm also collecting yo-yos. Are you familiar with yo-yos? Little kid's toy. I'm trying to teach myself tricks, but I own more yo-yos than I know tricks. So it's kind of a problem. I think it's a good investment, though, because I find that yo-yos have a very high rate of return. Thank you. Thank you. So I'm only sort of telling you all of this to brag. The point I want to make with sort of saying all this is I spend a lot of time not knowing what the hell I'm doing. I love that. I love that place where I'm an absolute beginner and I have learned to enjoy that process of just really sucking at something and then getting a little bit better every day until I actually know a lot about something. Oh, I'm being stalked. Because not all experiences are particularly pleasurable in the moment that we're having it. It's really after we have that experience, we look back upon it and we say, oh, that was actually a lot of fun. I really enjoyed learning how to yo-yo. I really enjoyed that horrible 8-mile hike in the woods when I thought I was going to die because of a bear. You know, it's afterwards we look back on these moments. And I got this early training at my college, home of the Moonbats. For those of you who don't know, Moonbat is sort of a hippie. It's a slang term for hippie. Surprise, I went to a hippie school. But Goddard is a Dewey school, and it's based on the principles of what they refer to as democratic education. And it's the idea that you can learn anything you want to through hands-on application. If you decide that you want to learn something, you go find somebody in the community who knows more than you and can help you or mentor you or at least give you some advice. And then you find a bunch of books and you find some other people. And that's how you build a major. I actually, at one point, had 5 college credits in Star Trek. I got 3 college credits for writing a paper picking apart a Pink Floyd song. It was really about that sort of journey of exploration and deciding what we wanted to learn as a community. And one of the declared values at Goddard is the following, and I'll read it for you. We challenge ourselves and each other to embrace uncertainty, to experiment, and to imagine unexpected outcomes. That's pretty good as a mission statement. It's pretty uplifting and pretty inspiring to me. Goddard taught me that I can learn and understand anything I want through open inquiry as long as I have a process for it. And it really has contributed to this sort of ongoing process of acquiring hobbies. One of my other hobbies, which I've really gotten to indulge here in Spain and particularly in Portugal, is scooters. This is my first scooter that I bought and ride around in Seattle. It's a 1979 Vespa, so it's old. I'm a little bit older. And it constantly breaks down, and I get to put it back together. This is the one I currently ride right now. It's a much newer one, but it's basically the same thing. And it's always breaking down. I've got to fix it, and I tweak the engine, and I replace parts all the time and upgrade. It's very upgrade heavy. And the reason I ended up buying a scooter is I was between hobbies, as you do. And I was talking to my dad. And my dad is a motorcycle guy. In fact, he was in a motorcycle accident when my mom was carrying me before I was born. And he was flat out forbidden to ever ride a motorcycle again. But then he retired recently and has gotten back into riding motorcycles. And I was talking to him, I said, Dad, I need a new hobby. I need something that isn't a computer game. I need something that isn't me sitting in front of a screen, that isn't reading Twitter all the time. And he said, why don't you get yourself a motorcycle so that we could bond over it or something. But his point was, and what he was suggesting was so that I could learn the mechanics of a small engine. Right, so these scooters have little tiny 2-stroke engines. They're about the simplest internal combustion engine on the planet. It's like a chainsaw or a lawnmower. They're not very powerful. They break down a little bit, but they're easy to take apart and put back together again. And in the process, he reminded me, as one time I was trying to fix it, I said, I don't know what's wrong with it. And he reminded me that an internal combustion engine only requires 4 things to work. Does anybody want to take some guesses at what those 4 things might be? Fire. Fuel. Yep. Fuel's one of them. Air, oxygen.
Oil.
No, they don't require oil.
Containment.
Containment or compression. I'm sorry?
Someone used the Kickstarter.
Raising money and then disappearing. Sorry, couldn't resist. Yeah, so an internal combustion engine only requires these 4 things to operate. You need to mix fuel and air together, and then ignite that very volatile vapor mix with a spark of some kind, or fire. And then you have to contain that explosion in order to drive the pistons. If one of those 4 things is missing, the engine will not work at all. So anytime you have an engine that doesn't work, you have 4 basic avenues to start looking at this. You can say, well, does it have gas? Is the air intake clogged somehow? Is the battery dead so I'm not getting an electrical spark? When I kickstart it, is it turning over and creating that spark for me when there's no battery? Is the compression bad somehow? Is it exploding but it's not containing that force? And that's the beginning of a very simple but extensive tree of options to help you diagnose what's wrong with your engine. And this applies to any internal combustion engine in the world. I don't care if it's a 79 Vespa or a 2016 BMW, that's how they work. And it's that simple process of having a rigorous way of inquiring about the state of the engine on my Vespa reminded me of all the other tools and processes that I use every day to try to find out why I can't get web pages to show up. Because that's my life. But when I expand out and look at more complicated systems, I'm often falling back onto the scientific method. So many of you may be familiar with the scientific method, but I'll go over it pretty quickly here. There's 6 basic steps. The first is to ask a question. You pose the problem that you're trying to solve. Why won't my engine start? Why is Redis crashing? Why did I use Mongo? Sorry, Mongo, I can't resist. The second step is you do your background research. What other information is out there? What resources do I have? Who do I know who knows more than me? Is there a playbook or a README associated with the service that I'm interacting with? Are there documents or API? You gather all that sort of stuff together, your reference material that's going to help you along the way, and to give you a basic understanding that you have in fact posed the correct question. The third step is you construct a hypothesis. You say, why is something like this? Well, if X is true, that would imply the answer to my question. Then you design an experiment. You test that hypothesis. In software, that could be like, well, I'm going to write the actual test. Or if I change that value that I think is causing the problem to, say, -1, what happens? And you observe it. You define clearly the information you don't currently have that you're seeking to gather. In the scientific method, then you analyze your data and draw a conclusion. Oh, well, when I change that value, everything runs 10% faster. Maybe I should leave that value alone. Maybe that's the problem. And then the 6th step is actually communicating out your results. In the scientific world, this would be publishing. In our world, that's actually committing the fix and pushing it out to production, or writing the blog post, or telling people in Slack, hey, I found that problem with Redis. Now, if you're at all familiar with the scientific process, you'll also notice there are 2 steps here that are missing, that are present in modern science. The first is write a grant proposal. And then down here between analyze your data and communicate is change your test results to match the grant. But no, this is the standard process by which science has moved forward over thousands of years. It's very, very consistent across disciplines. It's not just for scientists and academics. This is the process that I follow every single time. And this helps me, especially when I combine it with that first technique of starting at the very highest level. So I can say, well, what would be a good example of something that didn't work? Kafka isn't receiving messages from our application. Well, what are the 2 or 3 things about Kafka that could make that happen? And then I'll inquire about each of those 3 things. Are they actually happening? So for example, is Kafka running? Well, maybe it is, maybe it isn't. But I can ask that question very quickly. Is our app running? Are they plugged in? Can they ping each other across the network? Are we speaking the right protocols between applications? And I can sort of discover the broad categories of where things are going on and then drive home on more specific things instead of immediately assuming I need to upgrade a gem. Because the purpose of the scientific method is to make sure that the world hasn't tricked you into thinking you know something that you actually don't know. We fool ourselves all the time into assuming these very obscure reasons for an error. And the vast majority of the time, the fix to the problem is going to be 6 characters or less. It's some trailing comma or a missing quote, or we flipped a bit somewhere. You know, we're doing -1 instead of 1 because someone thought it was faster. So this simple process helps us avoid leaps of logic. Now, I said that I like to upgrade my Vespas because I'm kind of a speed freak. So I take the spare tire off because I'm never changing the tire on that thing, right? Like, why do I need to carry a spare tire around? And I'll strip that down. And I'll take the battery off because whatever, it's got a Kickstarter. You know, I can just kickstart it all the time. Yeah, I don't need those sorts of things, so it gets a little lighter. And then you can do this really cool thing where you change the little things that squirt the fuel into the cylinder and mix it with air so it gets just a little bit more fuel. Highly recommended that. The first time I did that, took my scooter apart, changed the jets, put it back together, kickstarted it, ran like a dream. So I hopped on, raced up and down the street for a while, got about a mile from my house, and it stopped. Dead. And of course it's Seattle, so it started raining. So what had happened? Well, I immediately went into a panic and figured that somewhere in that process I had disassembled or reassembled it incorrectly, which is weird. I had all the parts. I had no leftover parts, which is usually a problem with mechanics. I had actually cleaned the engine with engine cleaner to get rid of the grime and the grease and everything. I was certain, absolutely certain, that somehow I had gotten that cleaner into the fuel line or on the spark plug, which would have been disastrous. And after about half an hour of sitting in the rain, I realized that I was just out of gas. And I've done this time and time again. I've seen people do this time and time again with software, right? I mean, we've all done it, right? Like a production machine goes down, the website, for whatever reason, is down, and there's all of this pressure and all of this fear and all of this panic around you. It's really easy to lose sight that very often it is not Chinese hackers. It is not. You have not lost a hard drive in, there's not a backhoe fire somewhere that's taken down the data center. It's probably something very, very simple. And so tools that allow us to approach the software rationally from a process of how we ourselves handle our own human frailties in the process of inquiring into what that problem is, they help set us straight and set us on the right path to actually solving problems. And they also give us a framework for understanding after the fact so that we can learn from the experience. If you don't learn from an experience that you're having, you're not going to level up. You're not going to continue to expand your knowledge. You're just going to have done a bunch of stuff. Which kind of implies that you have to manage yourself in these sorts of situations. Because I don't think there's a single software system on the planet that exists that doesn't exist solely to fulfill some human need or desire. And every piece of software at some point, whether directly or on a second order, is interacting with humans at some point. And we're very, very messy. We make typos all the time. People enter their email incorrectly and then yell at us in support forums because they didn't get their activation email. Users can't type their passwords in right. They type their password, but they use an emoji, and our database can't handle an emoji. Or people use weird non-breaking spaces in their git commit file names, and that makes things messy. It's all of those sorts of things. That's all the sort of like the messiness of humanity. And we have to deal with that. We can't live only in the rational world of software, of ones and zeros and binary and trinary choices. I talked about being comfortable when you're having a new experience. The problem, in many ways, is that we work like this. Things are going along great. We just got a good review. Things are going well. They say, hey, we want you to learn a new language. Well, that's just dandy. I love learning new languages. I'm not going to be as productive. That's okay. So my performance is going to drop for a while. Sometimes a long while. As an aside, I'm learning Go right now, and I love it, and it's a lot of fun, but I feel like this. This is where I am. I don't know where I am, but I'm not as good as I am with Ruby yet. I'll get there, though. Because at some point, you get it, right? Like, you understand the context for the new experience that you're doing, the new information, you're integrating that into your worldview, you're learning things, and you improve, and you reach a new plateau of performance. And this is a very common graph used to describe education and learning, or the experience of it. We move in these plateaus. We don't move strictly in a one-to-one, constant, steady curve. And that's great, right? Like, this is normal humanity. But the problem is that we have this expectation of who we are and what we should be able to do. And when we're living in that valley, where we're not as effective as we could be, that we really begin to suffer, that we feel emotionally distant. We have lost our ability to make effective changes to our environment. We're worried about how our peers or our managers see us. You know, maybe you have a new review cycle coming up. In the last 3 months, you've been trying to learn this new language, and it's awful and horrible. And if you don't know and trust that you will come out of this and be a better developer at the end of it, that can be a really hard place to live. I said that I was a poker player for a while, and I love the poker community in that it's exceptionally rational, and it's also very much focused on emotion. Right? It's mathematics and psychology together in one. And there's a famous poker author, famous in the poker world, called Mike Kerri, and he coined this idea of the threshold of misery. And the threshold of misery is basically when you get to the point where things are so bad it doesn't even matter anymore. And he's specifically talking about loss aversion. So if you're a gambler and you say, I'm comfortable losing $500 and a night, and you might be comfortable losing 500 euros a night. Some people are, some people aren't. But if you get to the point where you've lost 5,000, does it matter? Does it matter if you lose another 50? Right? You're already down like 10 times what you thought you were going to be down. And conversely, if you win 50, does that even matter? Like, how many, you would take forever to get out of that hole. And I think we do this in our personal lives too, and development. You know, when like, I've done this where I'm like, well, I overslept my alarm by 2 hours. Guess I'm just going to play Overwatch the rest of the day. This is horrible. Or, you know, well, I've already had 3 drinks, so. Boy, I really should refactor this massive if-else block, but whatever, I'll just add another condition. I'm guilty of that one too. The data model's a mess, but I'll just add another column. And so those are kind of unprofessional choices, aren't they? You know, you're deliberately doing something that's a little bit worse. It's not the best choice, but it's an emotional choice because you're avoiding the pain. You're avoiding some sort of pain. And it's not that you're making these from ignorance or malice, but you see people who have crossed into this threshold of misery with their job or their experience of building software make these sorts of shortcuts all the time, and to not work at their best effort, not make the best decisions they can. And this is unfortunate when you find yourself in that environment, and some people do. Entire teams and departments can get to this place where nothing matters anymore. I've been at companies where we started laying people off, and if you're one of the people that are left, like, you're not really that lucky, are you? You know, because are you next? Are you still encouraged to do your best, most professional work? You have to be aware when you cross these sorts of thresholds, anything doesn't have to be this drastic, where you will be making less correct choices. And this will happen when you're troubleshooting in an outage situation, right? Because you want that pain to end. And it's really easy to make less good choices in those moments. And the secret really is to keep performing as if you care, right? Whether you care or not, or whether the circumstance warrants doing the correct thing in favor of the hasty thing. Because at some point, it will matter. It will have mattered that you did the right thing. It might not be today, it might not be tomorrow, but eventually. And you have to watch yourself and your peers, and by extension, everyone around you in your companies, to sort of see where people are. An engineer who's at or past the threshold of misery is looking for any kind of evidence that what they do matters. And if you can't show them that it matters, they'll go looking for that meaning somewhere else. And that might be a different project at your company, or it might mean a different company altogether. Wow, that got heavy. I really like The Karate Kid. I wouldn't say it's my favorite film. It's certainly my favorite Ralph Macchio film. In the poker world, we do this weird trick where we convince ourselves that we are the badassest people at the table, and no one there can beat us or figure out our tricks or read our soul to understand what cards we have. But then at the same time, we're ruthlessly analyzing ourselves away from the poker table to understand places where we're making mathematical mistakes. And we do this, I think we have to do this in software as well, where we have to believe that we can tackle or solve any problem when at the same time we have to be humble and realize that no, we don't have all of the answers necessarily. I like to manifest this by having weakly held strong opinions. So I said yesterday, right, that I don't care about Emacs and Vim. Well, I actually do. I have an opinion. It's just that I don't care. So if you want to hear my opinion about it, you can find me or we can talk on Twitter or something, and I'll tell you my opinion. But it doesn't really matter, because maybe I'm not right. I'm humble enough to believe that I don't have all the information. I might happen to be correct, but I haven't run the experiment to actually decide which editor is best, or which language, or which Git project, Git flow commit cycle is correct. But I want to hear what other people's opinions are and listen for the wisdom in that. It's when I apply that sort of rigorous rationality to it where I'm able to create a framework for myself to understand and explore the things that I don't know, and to admit that I have an opinion, but that I might be wrong, and that other people with a strong opinion as well. There's a reason why they believe that. And I can understand that through having a process for that. This slide is intentionally left blank. As I said, I was building it on my iPad, and I couldn't get a good screenshot of some of the open source tools that I actually use to give myself other ways to understand the systems that I'm working with. One of those is Rails ERD, which is a gem that I kind of shepherd these days. It generates an entity relationship diagram for your active record models. And when I'm working on a new project, I like to build one of these, and they're always gigantic because there's always hundreds of models and lots of lines going everywhere. And what I do with it, in the past, I've done this, I go down to my local copy shop or print shop, if you can find one that's still open in 2016, and you print it out in a giant poster, and you put it on the wall of the developer office. And it just changes my perspective. It just engages a different part of my brain in understanding how these models relate to each other. It's a different way of inquiring about truth. Because software is complex. Software is insanely complex sometimes. And when we're dealing with complexity, we open ourselves up to uncertainty, to places where we're uncomfortable. When we lack the sure knowledge, everything and anything becomes suddenly possible, and that can be very frightening. And one of those possibilities is our own failure. So I think it's important to consider what the story of our software is. It's not just enough to publish API documentation. We also have to understand how are our consumers actually using the dang thing? And what surprising use cases could they come up with that we never considered? Hopefully this isn't talking out of school. Aaron will tell me if I'm telling a GitHub inside secret in a hurry. But did you know that you can use gists as a database? There's an API for it, for creating and updating gists. So sometimes, every once in a while, a very clever JavaScript developer will turn their gist into a data store for their single-page app. And that's such a weird use case. Like, why would anybody do that? It's not performant. It's not going to scale. We're going to find you, right? Like, you're going to trip something. Like, okay, so yeah, your single-page app, great. You got onto Hacker News. It's popular. We see it instantly, and we shut you off. Like, why is that a good choice? But people do it. People do it because it solves a problem for them that they don't want to deal with databases. But as the complexity grows of software as itself and the environment in which the software lives in, it exposes really the limits of our rationality. It exposes the limits of our ability to comprehend what our software is within the world. There simply exists too many states, too many interactions for even our testing to be considered complete or barely even comprehensive. At best, it represents the limits of our knowledge of our software. When thinking about complexity, there's generally two kinds of complexity. There's applied and inherent complexity. And inherent complexity, it resists refactoring. It's like sometimes a thing is complex and it's just got to be that messy, right? Because that's the way the domain works, or we don't understand it enough to make it any simpler. There's a saying, at least in America, of Mark Twain wrote a letter once to somebody and said, I apologize for the length of this letter. I'm sorry it's so long. I didn't have time to write a shorter one. We don't always have time to do that refactoring cycle. We have a lot of pressure to get to green. And sometimes we're refactoring, but we're refactoring only within the context of our current knowledge of what this software needs to do. The other kind of complexity, applied complexity, is the stuff that's not inherent to the problem we're trying to solve. Sending a rocket to the moon is inherently a hard problem. There's lots of little subsystems. It's very, very complex. Applied complexity would be the bad ways that we would go about actually trying to accomplish that. So I think it's really important to understand where our systems are on the spectrum and how they represent it. I do a lot of work with postmortems. I love postmortems. Does anybody actually else do them when you have a problem or an outage? Awesome. I learned this discipline at Amazon, where after you broke the website, you had to write an email where the title was "How I Broke the Website." And they all went into an internal wiki, and people would post comments or suggestions, and it was like a way to as a group acknowledge that even the best among us would make dumb mistakes, and we would talk about as engineers, how do we avoid those in the problems in the future. And one of the frameworks for using these sorts of postmortems, or what we use in those to understand the complexity that we're dealing with, is the Kenefin model. It goes something like this. We assume that systems are either ordered or unordered. And unordered, and the difference here being how we perceive cause and effect. Now, in an ordered system, the system is constrained and behavior is predictable. Causality is either obvious from prior experience, or we can determine it by sitting down and tracing through the problem by analysis. A complicated ordered system might be, for example, a 5-star restaurant. Top line, it's great, it's always good. They can always do exactly the same meal over and over again, but it's a lot of complex, tiny little steps, but each one is individually clean. An obvious system might be McDonald's. There's a policy for everything. Everything is understood. Everything is weighed and measured and timed and factored for profit. Ordered systems can be taken apart and put back together again, just like my scooter. In an unordered system, they resist determining causality. Perhaps the link between them is several steps removed, or in the case of a complex system, it simply doesn't exist at all. If an ordered system is like my scooter, which I can take apart and put back together again, you can think of an unordered system more like an omelet. Once you make it, like you can't take the eggs back out, right? You can't get the original pieces back out and then put them back together again. I mean, I guess maybe you could like a centrifuge or something, like some like fancy laser, but you really can't. Now, over time, patterns may emerge. Patterns in our systems may emerge. And those systems where this happens can use more study, simplification to move them from the complex column to the complicated as we begin to understand the relationship between cause and effect. But an unordered complex problem is like a potluck where everyone brings a dish. You don't exactly know what everyone's going to bring. You might end up with all 5 people all bringing cheese. Maybe that's great. A chaotic system is more like asking your 3-year-old to make you lunch. It'll probably have peanut butter in it, if I know my niece, or my nephew, excuse me. So each of these types of system requires their own approach to troubleshooting. And although you can't use this sort of framework to make predictions about the nature of a problem in the moment, or you can use it to understand what kind of problems your system will encounter, and after the fact, the sorts of steps you need to take to move them towards less complex, less chaotic, and move them over to the right, where you can begin to make rational choices in understanding it. I love when there's bugs. Is that weird? Is that weird to say? No. I hear yes, I hear no. What I love about it is it means I don't know something, right? And I'm about to learn something weird about my system. I'm going to learn that people use GIST for databases. I'm going to learn exactly how much data I can cram into Redis. Like something new is happening in the world that my tests didn't cover. I'm going to learn something, and that's exciting to me. It's a little scary though, living in that place of discovery, and I have to be ready for it. Usually what's happening, I find a lot of times with bugs, is it's some piece of forgotten software that's happening. It's like a filter that we're applying to something, or we're not understanding the interaction that's happening. And this sort of exists as weird adaptive traits, right? Because software exists as this living thing. And so if we're doing a billing software, and we start generating reports, and we're sending reports to Bob in sales. Like every week, it fires off a report to Bob. Well, the company got sold, we got downsized, and Bob doesn't work there anymore. Whose job was it to remove that email report? Probably nobody's. So our app trundles away happily, generating a report to Bob every Thursday, even though Bob is like 4 companies, he's moved on. It's been several years. But who cares, right? It's not adversely affecting us at all. Until suddenly it does. Until suddenly that report is crashing because it's too big, or the mail server blows up in a funny way when it gets an email address it doesn't understand. It's a maladaptive trait. Just as large aquatic mammals like whales and dolphins still have vestigial feet. As humans, we have vestigial tails. We have a tailbone that we've carried with us. And it's only when adaptations to an environment hamper that organism's ability to survive that they will go away. And in software, this happens as well. Want to hear a horrible story? Can I tell you a horrible story? All right. I worked for a company, and we registered domains. Or rather, we would register domains on behalf of clients. And that's great. We cut a deal where the clients would pay us $15, and we were working with a registrar who only charged us $12. So we automated the whole process and earned $3 every time somebody's domain name came up for renew. And one day, our biggest customer called us up and said, hey, I noticed about 6 months ago you started charging me $30,000 a month more than you usually do. Could you please explain that? This is what we found. Now you have to imagine that this is a 200-line method of Perl-inflected Ruby. As a Perl developer, I'm certainly guilty of writing some obfuscated Perl, but this is the distilled version. Trust me, it was several screens of scrolling. Okay, so for every client, we look at all their domains. For each domain, we queue up a rescue job, an asynchronous worker. That's going to build the client on our internal accounting system. Then we're going to use the company that I work for, our internal corporate credit card, to register the domain. If the registrar returns an error, we're going to retry. We're going to retry 3 times, and if that still fails, we're going to requeue. We'll try it again in 5 minutes and exit. Where's the bug? People are mumbling that they understand it, so. Turns out, the corporate credit card, which by the way was hard-coded. Yeah, turns out that credit card expired. Which is great, fine, whatever. The registrar returned an error, we tried 3 times, and then we quit. We requeued the entire dang job. So then we get back at the top, 5 minutes later, we bill the client $15. We try to register again. Yeah, we did that to the tune of $30,000 a month for 6 months. She's my patron saint, I love her. I want to be her when I grow up. Okay, so I'm sorry, I'm running a little bit late, I apologize. Yeah, we had 600 domains, made $1,800 a year. It took myself and another developer pairing about 30 hours. Let's just ballpark and say it's $100 an hour for our time. We did not make money. We lost 3 years of profit to find this bug. And I went in and I did git blame. I said, oh man, who's the jerk who did this? It was not me. It usually is. In this case, it was another developer, and they were no longer with the company, not because of this. I read their comment, and they said, oh, the credit card expired again. Well, if you knew that, and that was just a maladaptive trait, right? That was just something that existed perfectly fine as long as everything is going fine until the environment changes. Something about the context of this piece of software has changed, and that is where the error came. Not necessarily that we should or should not have actually been offering this service, but that the world around us had changed. Our assumptions were different. We had to have a better framework for understanding what we're going to do into the future. Our ability to inquire about the nature of the software itself, our ability to understand the context in which it exists, and then our ability to rationally think forwards about it. Alan Kay famously said, or somebody claims that he said, that a change in perspective is worth 80 points of IQ. I explained this to somebody a few days ago in that every time I learn a new programming language, it's like I get another eyeball. Right? Humans have 2 eyes so that we can see slightly different pictures of a thing. And then we can gauge where it is in physical 3-dimensional space. That's what it's like learning a new language. You get another eyeball. You can see just a little bit more. You can have a little bit more precision. You can see more about that object. You know more truth about it. Successfully understanding the nature of code and being able to understand why it's behaving in a surprising manner requires you to shift your view and to question your assumptions. Understanding the problem that your system is trying to solve for your customers, what your customers are actually trying to employ the tool for, is critical to you understanding how you're actually going to fix it, not just for today, but the next time it happens. This is my favorite tool in the whole wide world. This is called a Crescent wrench in the United States. It's an adjustable wrench. I don't know if there's another word for it. I've carried these up and down ladders as a stagehand. I worked on stage for a number of years. I have one in pretty much every toolkit I have, from plumbing, even in my electrical toolkit. I've jammed open loading doors. I've knocked loose. I've pounded nails with it. I did not use it as a fuse once in a breaker panel. The show has to go on, folks. You can't let a blown fuse stop a good rock show. It's a very versatile tool, right? But it's a very simple tool. Just like all of the tools that we can use to inquire about our software are, really. The method of the scientific method, embracing that and applying it to the software, to not just troubleshooting, but how you're approaching your goals. Having a good framework for understanding what is the nature of the software that I have. What state is it in? Is it a complicated mess? Is it chaotic? Is it something I completely understand and there's great documentation for? Lets you plan ahead and also informs you how to solve those problems. Understanding yourself, how you respond to crisis, how you respond to positive things, how your team is doing, and understanding, having a framework to ask those questions. All those sorts of things are very, very simple things. They seem perhaps too simple on the surface. But having that framework for rational inquiry into the nature of what we do and how we do it and what it is we actually did is critical to us being successful in the face of chaos. So, thank you very much.